Okay, let's get started on page 211. There's 5 problems. I'm going to use my calculator instead of Desmos because Desmos is hard to show under the camera. So you're going to see the calculator, but it'll be basically the same thing. So we got to answer a bunch of questions about this. So I want to get going on this by first factoring the numerator and denominator. So I've typed in the whole f of x, but I've got just the numerator. And I want to just look at that first to see if I can factor it. So I'm going to graph the numerator, and it looks like it goes through 1, and it goes through it once, negative 1. So a factor is x plus 1 since it goes through negative 1, and there'll be some other stuff left, x squared and whatever, and I could divide this into there, but the rest of it does not make another 0. There's only the x plus 1 once. Now the denominator. This is easy enough to factor anyway. That's going to be x minus 2 and x minus 3. But I could also, I've typed it in so you can see I can turn that one off, turn that one on and graph it. And it goes through 2 and 3, so the factors are x minus 2 and x minus 3. Okay, from this, I can see that this didn't factor. It has complex or imaginary answers. So there's no factors that match, so there's no holes. And so there's a vertical asymptotes whatever makes the denominator 0. And the denominator 0 at 2, so it's x equal 2 is a vertical asymptote, and x equal 3. So in my graph, at 2 and at 3, there's a vertical asymptote there at both of those places. Okay, x-intercepts happen whenever the numerator of the fraction is 0, and that happens at minus 1. So it's minus 1, 0. And that appears to be the only one. The y-intercept happens when x is 0, so that would be 1 over 6. 0 in for x and 1/6. So it goes through 1/6 on the y-axis. Okay, now I want to do horizontal asymptote or maybe slanted asymptote. And in this case, since the degree of the numerator is more than the denominator, to get it, I would do long division, dividing this into that. I'm going to do that, even though on this assignment on 211, it didn't ask for the oblique asymptotes, it asked for just the horizontal asymptotes. And if it's a horizontal one and the degrees are the same, it would be 1 over 1 if these were both degree 3. If they were both degree 3 or degree 2, if they matched. If this was bigger, if this was upside down, this one was in the denominator, then that would be 0 if the degree of the denominator is greater than the numerator. But I got an oblique one here, so I'm going to take x to the third plus x squared plus x plus 1 and divide it by x squared minus 5x plus 6. X squared, I'd have to multiply by an x to get x to the third. So if I take x times all this, I get x to the third minus 5x squared plus 6x. Just multiplying all this by x. Draw the line and change all the signs. So this first one becomes minus, this one becomes plus, and this one becomes minus. And now I can add instead of subtract. And that's 0, and I get, these are like terms, so I get 6x squared minus 5x plus 1. X squared goes in there, plus 6. 6 times that. Excuse me. Oh, excuse me. I can multiply 6 by this, get stuff here, and I can do the subtracting, but I already have my line. It's y equals x plus 6. So it goes through plus 6. 1, 2, 3, 4, 5, 6, and it's y equals x, so it goes something like this. Okay, and this was a multiplicity 1 factor, so it goes in opposite directions on this asymptote. And this was also 1, so it goes in opposite directions on this one. So it goes through here, it goes through here, and it does not cross here, so it must go up like this. That's curious. See, it goes through minus 1, and it has to go towards that. And if it's opposite, it must go here, but that would have to cross, so it can't cross, so it must go back down, and then it must go, no, that something's wrong here. Let's take a look at it. I've got something messed up. So we got this, so I'm going to turn that one on and turn this one off and graph. I got that part right, and I'm in too close to see the rest of it, so I'm going to zoom out with 3, enter. And so it does, it comes from above on this, comes from the opposite side and goes up, yes. And there must be something down here, so I got to look down further. So I'm going to look down lower, like minus 100. That's up higher. Negative 100. Barely saw it down there. If I look further down, I'll see it, so minus 200. Yep. So it goes up, crosses, goes up on to infinity, then it has to be opposite, so it goes this way, and then it has to be opposite, and I was trying to keep it in here, but it's up here, following this slant asymptote. So x-intercepts, y-intercepts, vertical asymptotes, no holes, and that's the picture. Then I could talk about maximum here or minimum there, or doesn't look like this hits a minimum. It just kind of bends but keeps going up. Okay? Number 2. So number 2, I need to factor it. It's a big messy one, so I've typed that in also. So I'll just clear this one now. I come down and clear that and clear that. And I want to factor the numerator, so this should be the numerator. Turning it on, graph. On zoom 6. It goes through 1, 3, and a double at 5. That would be all 4 of them. So x minus 1, x minus 3, and x minus 5 twice. So that's completely factored. There's nothing extra to it. Now the denominator. So I'm going to turn that one off and turn that one on. Graph. And it goes, I must have typed something in incorrectly. Oh, it's 14x, not 4x. Missed a 1. Second, insert a 1. Okay, now let's graph it. So it goes through 1, 2, and 4. So the factors must be x minus 1, x minus 2, and x minus 4. Okay? So there's it factored. So this time I do have one matching factor, so there's got to be a whole. And to figure out, that happens at x equal 1, but to figure out the y value, I use just the simplified form. That would be just this part, and put 1 in there. So this is minus 2, and this would be minus 1 in there would be minus 4 squared would be positive 16 over 1 in there would be negative 1, and 1 in there would be negative 3. So I get minus 32 divided by 3. So that's where the whole is. Vertical asymptotes. That will be whenever the denominator is equal to 0 except for the whole. So there would be x equal 2 and x equal 4. And let's see, hopefully I don't run out of time here. What do I want to do next? Oh, x intercepts. So that's a whole, but there's an x-intercept at 3, 3, 0, because 3 makes the numerator be 0, and also one at 5. And this is a double, has multiplicity 2, so there's going to be a bounce there. And y-intercept is when I make x be 0, it'll be easiest here. That's 75 divided by negative 8. 0 for x, and 75 divided by negative 8, which is almost 10, 9 point something. 9 and 3/8. Okay, and the asymptote, horizontal oblique, well, that will be, again, we're going to have to divide, and that's going to be really messy, so I'm not going to do that one on this one. It would be this divided in there. It would be x plus or minus something, and I don't know what that would be. Yeah, I'm not going to, I could do it. It wouldn't take very long, but let's just kind of graph what we know. So it has a hole at 1 and almost minus 10 and 2/3. So way down here at minus 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 and 2/3. There's a hole. Has a y-intercept at negative 9 something. Has an x-intercept at 3. Has a double intercept at 5. That's a double. And let's see, 1, 2, 3, 4, 5, and this is minus 3 to get some units. And we have a vertical asymptote at 2 and at 4. And these asymptotes were single multiplicity, so it goes opposite direction at each one of these. So if it goes through here, hits this hole, it looks like it's headed this way. And there is a a slant asymptote. I didn't figure out where it's at, but there's a line going across. It goes opposite, so it must come down, and if it goes through here once, it must go this way, and then here it must come down and bounce, and then follow that line wherever it is. So this goes off to infinity, this goes to negative infinity, that goes positive infinity, this goes down here and follows the line wherever that line is. Let's take a look at it and see if we're correct. So we come down here, and that should be this one. Enter and graph. And we saw a little bit there, and there's the down part, and there's it going this way. The line must go through here someplace. I can look down a little bit further. 15. So it's following the line, then it drops down, and there, and there, and there's a hole at, that's the other one, we don't need that one, but second, calculate the value at, we said the hole was at 1, and it says at 1, there's no y value, there's a hole there. Okay. And I'm going to stop there and make a video of the other ones after this.